Hello everyone, we continue with our problem solving, and now we're going to solve the second question of this 2020 Necta mathematics exam. And now the question is question number 13 in this past paper. We're asked to find the matrix A if A inverse is this one. The inverse of a matrix A is this one, 4, 5, 3, 2. Now find the matrix A. Now for information is that if we are given an inverse, which is this one, now to find the original matrix, it is enough just to find the inverse of the given inverse. If we will be finding inverse of an inverse and then calculating the inverse of that inverse and calculating the inverse of the new inverse, we will be alternating between the inverse and the original matrix. Now, if we find the inverse of original matrix, we'll get this inverse. And if we find the inverse of this inverse, we'll get back the original matrix. And now, let's find the original matrix from this inverse, which I said we have just to apply the rules of finding inverse of this inverse. Now, we have A inverse, which is equal to 4, 5, 3, 2. Now, the inverse of this one, the inverse of A inverse is equal to A, which is equal to 1 over the determinant of that inverse multiplied by this matrix, but we are going to exchange the positions of the leading diagonal. It means we're going to put 2 here instead of 4 and 4 here instead of 2. And also we're going to change the signs of these main diagonal elements. Now it's 2, 4, -5, and -3. Now we have to find the determinant of this inverse first. Now determinant of the inverse of matrix, this one, is equal to the difference of the product of the elements of the leading diagonal and that of the main diagonal. Now is equal to 4 times 2 minus 5 times 3, which is equal to 8 minus 15. This is equal to -7. And therefore determinant of this inverse of matrix A is equal to -7. Now in order to get A, we say is 1 over 7, which is equal to negative, then multiplied by 2, -3, -5, and 4, which you get A is equal to -2 over 7, 3 over 7, 5 over 7, and -4 over 7. Now the original matrix A is equal to -2 over 7, 3 over 7, 5 over 7, -4 over 7. Now the answer is this one. The original matrix is this one. Now if we try to find the inverse of this matrix, we will find this one. Now that's section A. Let's continue with section B. We have Amani and Asha bought Coca-Cola and Pepsi drinks for a farewell party. Amani spent shilling this one to buy 12 bottles of Coca-Cola and 5 bottles of Pepsi drinks. Asha spent Tanzanian shillings 8,150 to buy 9 bottles of Coca-Cola and 5 bottles of Pepsi drinks. Now formulate a system of linear equations and hence apply the matrix method to find the price of 1 bottle of each type of the drinks. Now we have Coca-Cola, and Pepsi drinks. We have Amani and Ash. Now we have been told that Amani spent 9,950 Tanzanian shillings to buy 12 bottles of Coca-Cola and 5 bottles of Pepsi. 12 bottles and 5 bottles. And Asha spent 8,150 Tanzanian shillings to buy 9 bottles of Coca-Cola and 5 bottles of Pepsi drinks. Now, if we represent the Coca-Cola bottles by X and the Pepsi bottles by Y, we let X represent Coca-Cola bottles and Y represent Pepsi bottles. Then we have, in a system of linear equations, we have 12 bottles of Coca-Cola plus 5 bottles of Pepsi is equal to this one. And have also 9 bottles of Coca-Cola plus 5 bottles of Pepsi is equal to 8,150. These are our linear equations. And if we change them, since we are asked to find the price of one bottle of each type of the drinks by applying the matrix method, now we have to change these linear equations into matrix form. Now, in order to do that, we say 9,950 and 8,150. This is equal to X and Y multiply by 12, 5, 9, and 5. Therefore, this is our matrix form which we are going to use in order to calculate X and Y. This is the same as saying that 12,595 times X and Y is equal to 995,815. You see, we have a matrix here with 2 by 2, which is multiplied with X and Y. And therefore, since we want to find the value of Y, we have to eliminate this part here and to make everything in this side so that we will have the value of X and Y. Now, by doing so, we have to multiply by the inverse of this matrix both sides. Now, first of all, we have to find the inverse of this matrix. And now, how to find the inverse of this matrix? We have first to find the determinant. Let's say this is matrix B. Let this be matrix B. And now, determinant of matrix B is equal to the difference of the product of the main leading diagonal and the main diagonal is equal to 12 times 5 minus 9 times 5, which is equal to 60 minus 45, which is 15. Now, determinant of this matrix is 15. Now, its inverse is 1 over 15 times, we exchange the values of the leading diagonal, of the element on the leading diagonal, and then we change the signs of the element on the main diagonal. Now we put 5, we put 12 here, we put negative 5, and here negative 9. Therefore, B inverse is equal to this one multiplied by this one, you get 1 over 3. This one multiplied by this one, you get negative 1 over 3. This one multiplied by this one, we get 3 over 5 negative. This one multiplied by this one, we get 4 over 5. 4 over 5. And therefore, this is our inverse of this matrix. If we multiply this by this one, we get an identity matrix which is equal to, now we get B times B minus 1, the matrix B times the inverse of its matrix is equal to an identity matrix which is equal to 1, 0, 0, 1, which then we multiply this identity matrix by this x and y, which gives just x and y. And then we multiply again this inverse of matrix to the other side in order to get the values of x and y. And now we can write x, y is equal to this inverse multiply by 9,950, 8150, and here you get is equal to this times this one, it's equal to just dividing this by 3. This times this one is equal to we say 9,950 over 3, then minus this times this one, which is equal to 8150 over 3, and then this element times this one is equal to negative 3 over 5 times 9,950, then plus this times this one, 4 over 5 times 8150. We have a new matrix here, it's x and y. Therefore, we continue with our solution. We have 9,950 over 3 minus 8150 over 3. Then here we have 3, negative 3 over 5 times 9,050 plus 4 over 5 times 8,150. All this is equal to x and y. Now we have the denominator, which is the same, so we have to subtract this number from this one with a common denominator. This is equal to 0 minus 0, 5 minus 0 is equal to 5, 0, 0. 9 minus 1, 9 minus 8 is equal to 8, 1 over 3. And here we have a common denominator. Therefore, we have to multiply. We have to divide to divide this 5 from this one. I have to eliminate this number 5 at the base first. Now, 9 divided by 5, we get 1, left is 4, 49, 9 is 45, we have 4, 45, 9, and then 0. So we eliminate this and this. And here we have 8, which is 1, left with 3, 31, 6, and 1, 15, 3, and then 0. This multiplied by 4 and this multiplied by 3 now is equal to 3 times 0. We have, this is negative, we have negative 0. 3 times 9 have 27. 3 times 9, 27, 29. Then 3 times 1 is 3, and that 2 have 5. Then plus 4 times 0, 0. 4 times 3 is 12. 4 times 6 is 24, and 25. And 4 times 1 is 4, and that 1 is equal to 6. Now x, y will be equals to 1800 divided by 3, we get 600. And here, this one minus this one, we get 0. 0 minus 0, 0. 12 minus 7, we get 5. 4 minus 9, we get 5. Then we have 5 minus 5, which is equal to 0. And this number is positive. And therefore, by this solution, we can say that x is equal to 600 and y is equal to 550. And since we let that x represent the number of Coca-Cola bottle drinks and y represent the number of Pepsi bottle drinks, then you can say that one bottle of Coca-Cola drink is equal to cost 600. We say that one bottle of Coca-Cola drink cost 600 Tanzanian shillings. Its price, this is the price. And also one bottle of Pepsi drink cost 550 Tanzanian shillings. Therefore, we were asked to use the matrix method to find the price of one bottle of each type of a drink. Now we got the price of each bottle of one bottle of each type of drink is price of one bottle of Coca-Cola is 600, and the price of one bottle of Pepsi drink is 550 Tanzanian shillings. Therefore, we continue with the last section, section C. We are given point A, which is equal to this one, is reflected in the line y plus x is equal to 0, followed by an anticlockwise rotation through 90 degrees about the origin. Now we ask to find the final image of a point A. Now let's do this equation using the laws of reflection and rotation. Now how we do it is that A is 4, 2. We have two equations which are used to find the rotation of points and the reflection of points. And these equations are, for reflection, we have x and y. These are the image after the reflection is equal to cosine of 2 alpha sine of 2 alpha sine of 2 alpha, and here minus cosine of 2 alpha is multiplied by x and y. This is the given point. This we call this matrix of reflection where alpha is the point, is the angle, alpha is an angle made by the axis of reflection with the positive x-axis. Now if we have xy plane, we have this is the positive x-axis. Now alpha is the angle made by the reflection. If we are asked to find the reflection on this plane, which is x is equal to y, now the angle made here is equal to 45 degrees. If we are asked to find the reflection on this plane, y is equal to negative x, then the angle is this one, is 90 plus 45, which is equal to 135. And if we are asked to find the reflection on this line, which is the same with this one, x is equal to y, we use that angle, 45 degrees, and vice versa. And if we use, we are asked to find the reflection on the x-axis, it means the angle is equal to 0, because the angle made by the reflection axis, the line of reflection, and the x-axis, since it itself, then it is equal to 0. If we ask you to find the reflection on the line y, on the y-axis, now the angle made between x-axis and y-axis is 90 degrees. Now to perform a reflection on this angle on the line y plus x is equal to 0, let's M denote reflection on y plus x is equal to 0, y plus x is equal to 0 of a point 4, 2, which will bring our image. Now reflection of this point on the plane y plus x is equal to 0 bring this image. Now by using our formula, the line y plus x is equal to 0 is equal to the line y is equal to negative x. If we move x to the other side, we get y is equal to negative x. Now the angle made between the positive x-axis and the line y is equal to negative x is equal to 135. Now our image, if we plug alpha by 135 degrees, now we get our image here on this question will be equal to cosine of 2 times 135, which will be 270 degrees, divided by sine 2x, sine 2 alpha, which will be the same angle, 270 degrees, have sine 270 degrees, have also cosine 270 degrees. This multiplied by 4 and 2. Now, if we find cosine of 270 degrees, we get how much? Cosine of 270 degrees is equal to 0, and sine of 270 degrees is equal to negative 1. Now x, y, cosine of 270 degrees is equal to 0, and sine 270 degrees is equal to negative 1. Now we get negative 1 here, negative 1 here, and here we get 0 multiplied by the angle. Now our image is equal to 0 times 4 plus negative 1 times 2, which is equal to negative 2. And here we have a negative 1 times 4 plus 0 times 2, which we get negative 4. Therefore, our image after reflection on the line y is equal to y plus x is equal to 0 is this one. But on our equation, we were asked to find the point, the image after the reflection and rotation. Now, as I have told you, this was the matrix of reflection, and now we are going to the rotation. I will write to you the matrix of rotation. Now, as usual, image, and now is double x double image. The image of our image is equal to cosine of alpha negative sine of alpha sine of alpha cosine of alpha. The matrix of rotation contains only alpha and not 2 alpha. Is only alpha, is 1 alpha. Now the angle is not multiplied by 2 as we saw here. Now multiply by the image after the reflection. Now our image, the final image, let's call this the final image, is equal to cosine of 90 degree. Because the rotation we were told is rotation around 90 degree. Now cosine of 90 degree is equal to 0, and sine of 90 degree is equal to 1. Is equal to 1, and therefore our matrix of rotation becomes 0, negative 1, then 1, 0. This multiply by our image, which is negative 2 by 4, negative 4, and this equals 0 times negative 2 plus negative 1 times negative 4, we get 4. 0 times 2 times negative 2 is equal to 0. We get 4. Now we get 1 times negative 2 plus 0 times negative 4. Here we get negative 2. Therefore, this is our final image. Our final image is A, which is equal to 4, negative 2, which we say x, y. Our final image is equal to 4, negative 2. This is our final image. And here at the reflection and rotation, there is something else I have to tell you. There are relations which are used in the reflection, which can simplify your problem solving. If we do not aim a reflection, then we say that, and this is proven, we say that the reflection of a point xy on the x-axis, if the reflection is made on the x-axis, the image obtained will be the same point x and y, but y change in sign. The sign of y change. Now the image obtained will be x and negative y. So if we had 2 and 4, and then the image will be 2 and negative 4. Then if we have the reflection on the y-axis of x and y, then the image will be x and y the same, x and y, but x change in sign. Now you have negative x, y. Now you can see that on the x-axis, y change sign, on the y-axis, x change sign, this way. Now if we have a reflection on the plane, y is equal to x of this point, reflection of this point on this plane, y is equal to x, then we will have the image which is y, comma, x. Our image will be y, x. If we had 2 and 4, then the image will be 4 and 2. If I had 2, 4, the image will be 4, 2. The value of x on this point will be the value of y. At the image, that value of x on the original point become the value of y on the image, and the value of y become the value of x. Now, example, if we have reflection on the y is equal to x of 4, 2, then the image will be 2, 4. This is our image. Now, reflection, another reflection on the y is equal to negative x of a point xy, then the image will be here we saw there is exchange of the positions. Here also we have exchange of the positions y and x, and also we have change in sign of both values. Therefore, if we had example, deflection on y is equal to negative x of 4 and 2, then this will be equal to 2, 4, all of them negative. If we take the example of the question we are given, is exactly I have solved. The point A, 4, 2 is reflected in the line y is equal to x, y plus x is equal to 0, which is this one, y is equal to negative x. Now, in order to find the image after only the reflection, then we will get this one, where is how I solved here and get only after reflection get negative 2, negative 4, which is this one, negative 2, negative 4. So if you can use only this relation, if you can remember this relation, you won't have to go through all the formula of this matrix of reflection. Therefore, that is the end of our question. Thank you very much, and see you again.